Hello guys, today we will be talking about your 8th lab. In this lab, we will be designing a simple calculator. Our simple calculator will have 6 different operations. These are multiplication, addition, subtraction, taking the power by 2, incrementing by 2, and decrementing by 2. This design will have 2 inputs called data in and valid in. We will talk about these inputs later. And we should also say that your output will be a single output called data out. So for this design, you're going to design a state machine. This state machine will either execute in 2 states or 3 states based on your operation. Now, let's take a look at our block design. Here you can see our block design and our inputs and outputs. So on the input side, we have reset, clock, valid in, data in. So reset and clock should be obvious to you by now. They are the same as the previous labs. The valid in input is your confirmation button. So it is a single bit input, so we can use it as a button. So you use this button when you want to confirm that you have made an entry. We will go into more detail when we're talking about examples. And then here we have data in input. This data in input is an 8-bit input given by the switches on your FPGA. And then finally we have our output data out. This is represented by the LEDs on your FPGA. So now let's take a look at our design behavior. So as we've discussed, we have the following operations here. So each operation has a corresponding number to it. So multiplication operation has the number 0 corresponded to it. Addition is 1, subtraction is 2, and so on and so forth. Now, there is an important distinction to make here. You see, these 3 operations take in 2 numbers. So in order to do multiplication, you would need a number and then another number. For addition, number and another number. Same for the subtraction. But when taking a square, you need only 1 number. And same for decrementing and incrementing. So this is why some operations take 2 states while the others take 3 states. Now, in order to understand our design better, let's take a look at our state machine. Here we have our state diagram. Here we can see the inputs valid in and data out. So, for example, here is the initial state. So, in the initial state, you should wait for your number. The user should enter their number and then press the valid in button. So, how do we read this from here? While valid in is 0, your data out is 0. So you should see 0. So all the LEDs should be turned off on the FPGA. They should keep going until your valid in is 1. So this should be 1. There's a mistake here. So when valid in is 1, your data out should be equal to the number. So this number here is your data in. So the user entered that number through the switches, and your data out, your LEDs should show this when you press the valid in button. Also, another thing to know is that you should store this data in because you will be using it on your later states. So here it is shown as number equals data in. So data in has been stored in number. Okay, now let's go back and look at, let's go forward and look at the next state. So here in the S1 state, you can see that while valid in is 0, meaning that while the button is not pressed, your data out should be equal to number. So same as here, your data out should be the number that you entered in your S0 state. And then when you press your valid in button, two things can happen. You can either go back to S0 or S2. Now this depends on which operation is chosen. So in order to choose an operation, the user should enter a value through the switches. So as we've discussed before, each operation has a corresponding number. So if I wanted to do multiplication, I should enter 0 from the switches and then press valid in. So if we did multiplication, this would be true because operation would be equal to 0. In this case, your data out, meaning that the LEDs on your FPGA, should be equal to the operation. So for multiplication, that would be 0. But if you choose one of these 3, 4, or 5, meaning that square, increment, or decrement operations, you're going to go back to your S0 state. Why? Because we don't need to get another number. We can simply give out the result. So what we see here is the data out, meaning your LEDs should be equal to your result. So in here, you should calculate your result and then put it in your data out. And then let's go to your S2 state. So let's remember that S2 state is when you're using one of these operations, 0, 1, or 2, meaning that it is an operation taking two numbers. So again, another thing to note is that you should store your operation, meaning that you should store the data in value that you entered here in a variable which could be called operation because it will be used in the next state. So in the S2 state, while the button is not pressed, your data out should be equal to your operation. So it should be equal to the number you entered in your previous state. And then when you press the button, the data out should be equal to your result, which is the value you calculate based on your operation. And once that's done, you can go back to your S0 state. Here we have two examples. The first one is an addition example. We're going to do 6 plus 3. So in order to do this, first thing you do is enter 6 with the switches, and then you press the valid in button. And then you release it, and then in order to do addition, what do? Let's look. Addition is 1. So next, you should enter 1 here. Once you enter 1, you should press your valid in button again, and then release it. And then, in order to enter 3, you should enter 3, and then press valid in. And after you do this, you should see your result. The next example is a decrement by 2 operation. In here, you're going to take data in and enter 7 through your switches. You're going to press your valid button. And then, in order to decrement, let's see. So decrementing is 5. So you're going to enter 5 and then press valid in. And then your data out will be 5 because 7 minus 2 is 5. Next up, we're going to see the synthesis of the project. Here, I have created my project. Once I'm done, I'm going to synthesize the project. So I double click the synthesize project. Now you're going to get a couple warnings here. So we've had these warnings, the delay warnings in the previous labs, and we've already said that they are not important. But now we get a warning about an 8 by 8 multiplication. So when you do an 8 by 8 multiplication, 8-bit by 8-bit multiplication, what do you get? You should get a 16-bit result. But we are unable to display 16-bit results in our 8-bit LED display. So what we do is that we only look at the 8 least significant bits. So here the synthesizer is warning us about a overflow happening because you are putting a 16-bit value into a 8-bit register. So it's saying that the most significant 8 bits are going to be lost. And then we already know that, so this is not a problem. You can also ignore this problem. This is it for part 1. In part 2, we will see the simulation of the design.
Hello everyone. Just before moving on to the second part of this lab, I would like to remind you that also for the simulation in Xilinx, you need the data and result files copied into the project folder, which is actually reminded here. And what we mean by that is we will be giving you where is it? Okay. We will be giving you these files as well on LMS, and what you need to do is you just need to copy these files and then paste them into your Xilinx project folder right here. I'm not going to do that now. I'm going to show you how it will work without the data and result file, how it will result in errors. And let's simulate our model, and let's see. Okay, as you can see right here, there are some output errors, and it didn't even completely run our simulation. And that's because the data referenced file, the file that is named data that is referenced on this folder cannot be opened for reading because it's not there. So, which is why we need to, hold on, not this folder, we need to paste these data and result into here. And as you can see, data and result are pasted here. And if we relaunch our simulation from this button, it should be visible that it will give true values and that the design contains no errors. So that's how that should be done. Let's also simulate our design on virtual FPGA. And let me open up virtual FPGA. And I also have this PDF right here to remind me what operations each decimal values correspond to. So let's get our file from the Xilinx project folder, which for me is in desktop and Lab07. And here we're going to use this file which we've designed in this lab, but not this one, since this is just for the test batch part for Xilinx. We just add this V file, and then we get our top wrapper, which is here, which should be on LMS. And after clicking done, we can click start and see it start. Let's see. And after this part, before going on to the next part, there will be also a short video on how this design works on an actual uh, FPGA, so you can see. And let's see, it must still be compiling. Give it a moment. Okay, it's coming together. Okay, we need to click on reset, which is the 0 indexed button, which is actually told that it is so here. And let's get back to the design. And let's do, for example, 3 times 2. So that's 3. And as you can see, 3 has been taken as the operand. And let's do 0, which is multiplication, and then 2, which will result in 6, as you can see. And also let's do, for example, addition, which we can do like 1 and plus, which is still 1, and then plus 2, it should be 3. As you can see, it works. And also you can press the reset button to reset the LEDs and the variables as well, but I'm not doing that since it should work still with this operations. And let's do result equals number plus 2. Let's do 3, and then what's 4? Okay, our operation is 4, so we click on this one, and then what happens is that since we've done 3 plus 2, it just goes to show you that the result is going to be 5. And let's do one more, which can be result equals number minus 2. So let's do, for example, 3 minus 2. So we need 5. And as you can see, we got 1. And that should be basically how the design should work. And you can also see how it works on and basis 2 FPGA after this part.
Hello guys, in this part we'll be taking a look at simulating your design. In order to simulate your design, switch to the Simulation tab, click on your testbench file, and then double-click Simulate Behavioral Model. Now before I click this, I should say that we've been getting a lot of questions about this. So when you're simulating, you should make sure that the test bench is highlighted, not your design file. So don't do this. Click on your test bench first and then simulate. So my simulation has been done. Now let's see the results. Now for this simulation, we will take a look at data out, data in, and valid in. In order to observe these better, I'm going to convert data out and data in to unsigned decimals. So here I press here and then unsigned decimal. Right click, radii, and then unsigned decimal. In order to make our simulation easier, I'm going to bring up an image. This image here was taken from your slides, so I'm going to put this down here while doing the simulation. So let's start from the data in. Here we see that data in was given 4, and in order to confirm this input, valid in was given 1. So this means that the input 4 was given from the switches, and then valid in button was pressed once. So this should confirm the input 4 as our first number. And as you can see, we have 4 on data out. So if we were to trace this from our design here, we are currently at S0. And then while the valid in is 0, we're displaying 0, as you can see here. And then when valid in comes here, data out is equal to our input, which is also the number. So now we have transitioned to S1 state. So let's see what's going to happen now. So now our input is 0. So in this state, we're supposed to enter an operation. So what is 0? 0 is multiplication. So we have entered as 0, and then we have pressed the valid button. So now what should happen? It was displaying number up until now. I've pressed valid and my operation is 0. So this transition is going to happen, meaning that my data out is going to be equal to my operation. So my operation was multiplication, meaning 0. And here you can see that I'm displaying 0. So now we have transitioned to the S2 state. So in this state, we're going to get the second number. So while the valid in is 0, we just display the operation. And then once it becomes 1, we're going to calculate the result and then enter it to the output. So what happens here? I've entered 3. I've pressed the valid button. So what's going to happen? Our number was 4. Our current data in is 3. So 4 times 3 should be 12. And if we look at the data out, one cycle after the valid in, we see 12. So that was one operation. So let's look at the next one. Here we have entered 4. Oh, and also I should note that here we did this transition after displaying the result. So this transition happens after you've displayed the result. So now I'm back at the S0 state. Okay, so back at our second example, I've entered 4. I've pressed valid. I'm displaying 4. We've switched to the S1 state now. I've pressed 1. I've pressed the valid in button. I'm displaying 1, which is an addition. And then I've entered a 3, pressed the valid button, and then I get 7. Why? Because we did 4 plus 3, which is 7. So now we've finished our multiplication and addition tests, and then next up we have our subtraction test, but that is very similar to the previous ones, so I'm going to skip this. So let's look at our square example. Our square example starts here. So currently I'm at S0. I've entered 8, which is going to be my number. I've validated it. So right now my data out is equal to 8 on my number. Here my data out has been equaled to 8. Next, I'm going to enter my operation. Here we can see that a 3 has been entered. What is 3? 3 is number times a number, meaning square of a number. So what's going to happen here? I'm at S1. I've received a valid equals 1, and my operation is equal to 3, meaning that we're going to do this transition. We're going to transition to S0 while my data out is equal to the result. So let's look at it here. I've entered 8 for the number, 3 for the operation. Once I validated it, 1 clock cycle later, I get 64, which is 8 times 8. Next up, we have our increment operator, which is very similar to our square operator. So for this one, we've entered a 9. Remember, we're back at S0. So we've entered a 9, pressed valid. This is going to be stored as the number, and this number is going to be displayed on the output. Here, as you can see, 9 has been displayed on the output. So we've transitioned to S1. Let's see what's happening here. In this state, for the operation, we've entered 4. So 4 is increment by 2. We have validated it. So here, operation 4 is included in this transition here, as you can see. So right now our data out should be equal to our result. So 9 plus 2 should be equal to 11. So my result is equal to 11. Next we have the decrement by 2 operation, which is very similar to the previous one, so I'm going to skip this as well. Once you've done this simulation, you should look at your console and see that for each test you're getting the right value. And then if you had no errors, you should get a design contains no error, well done message. Once you receive this message, you have completed your assignment.